Hello everyone, welcome to my channel on engineering mathematics. In this video, I am going to discuss the concept of ANOVA test and examples based on it. Let us see the points that I am going to cover in this video. First, we will see introduction to ANOVA test. Then we will see what are variance within groups and variance between groups. Then we will see types of ANOVA test. Next, we will see assumptions for ANOVA test. Then we will see steps involved in ANOVA test. And finally, we will see some examples. So let us proceed with first point, that is introduction to ANOVA test. The ANOVA test, which stands for analysis of variance, is a statistical method used to compare the means of three or more groups to determine if there are any statistically significant differences between them. It is commonly used in research studies where multiple groups or categories are involved. For example, imagine you are testing 3 fertilizers on plant growth. ANOVA would help to determine whether the growth differences between plants treated with these fertilizers, say A, B and C, are significant or just random. It is an extension of t-test. If ANOVA is used for 2 samples, then its result is as same as that of the t-test on those 2 samples. Test statistics for ANOVA is f-test, as it determines if the variability between the group means is significantly larger than the variability within the group means. The f statistic formula is given by variance between groups divided by variance within groups. Later on, we will see these two concepts. A large f value suggests that the group mean are different enough to not be due to random chance. Therefore, if variance within groups is smaller than the variance between groups, then f is large, which indicates differences of mean observed is real and not by any random chance. Now let us see what is variance within group and how to calculate it. Let us understand this concept with the help of an example. Imagine you are studying the effect of 3 fertilizers, namely A, B and C, on plant growth, and you measure the growth of these plants in centimeters for each fertilizer type. So here these are fertilizer names. These figures indicates the growth of the plant in centimeter, and these are the group means. So mean of A is written over here, mean of B is this, and mean of C is this. Next, I write down variance within group formula, which is summation of individual data point minus group mean the whole square divided by degrees of freedom. Now let us see how to calculate variance within group A using this formula. Here individual data points are 20, 22, 19, 21 and 20. So I'm going to subtract this group mean from each of these individual data points and I'll take square of it. For example, it will be 20 minus 20.4 the whole square plus, due to this summation, 22 minus 20.4 the whole square plus 19 minus 20.4 the whole square plus 21 minus 20.4 the whole square plus 20 minus 20.4 the whole square, whole divided by degrees of freedom. It is given by n minus 1. Since there are 5 samples, so its degree will be 5 minus 1, that is 4. So when we calculate this, I found variance within group A is 1.30. Similarly, you can calculate variance within group B and variance within group C. You can pause the video and check these calculations. Here, group A has variance 1.30, meaning that the plant growth in this group is not highly spread out. That means most of the values are close by the group mean 20.4. Group B has higher variance, that is 2.50. It indicates that more variability in plant growth in this group. That means the growth of the plants is somewhat away from this group mean. You can see some of the plants grows up to 28 centimeters, which is far away from 26. Now let us see what is variance between groups and how to calculate it. For that, we use the same previous example of fertilizers. Here, first we calculate overall mean. For that, we add up all these data values and we will divide it by the sum of all data points. So there are 15 data points and I found overall mean is 25.4. Next, we calculate the weighted square deviation of group sizes. It can be calculated using the formula Ni into xi bar minus x bar the whole square, where Ni is size of each group. Here we see each group has size 5. So N1, N2, N3 are 5. Xi bar means group mean and x bar means overall mean. So here xi bar is 20.4 minus overall mean is 25.4. So 20.4 minus 25.4, which is minus 5 square is 25. Next, group mean is 26.0 minus overall mean is 25.4, which is 0.6. 0.6 square is 0.36. Similarly, you can see that 29.6 minus 25.4, the whole square will be 17.64. So this is weighted square deviation. We use this weighted square deviation to calculate variance between groups. Variance between group has formula sum of the weighted square deviations divided by the degrees of freedom between the groups. So these are the weighted square deviations. Let's calculate their sum. I found it is 215 divided by degrees of freedom between groups. Since there are 3 groups, so degrees of freedom will be 3 minus 1, that is 2. So 215 upon 2 is 107.5. This is variance between groups. I hope guys you understood the concepts called as variance within groups and variance between groups and how to calculate it. Note that variance between groups quantifies the effect of the independent variable. Here that independent variable is fertilizer on the dependent variable, that is plant growth. In this case, the variance between groups is 107.5 indicates a significant difference among the group means. Group means were 20.4, 26.0 and 29.6. This suggests that the type of fertilizers has the measurable impact on plant growth. Next, we will see what are the types of ANOVA test. There are 2 types of ANOVA test, one-way ANOVA test and two-way ANOVA test. One-way ANOVA test has one factor or one independent variable. It compares 3 or more levels of one factor, whereas two-way ANOVA test is an extension of one-way ANOVA test. It has one or more factors or independent variables. It compares the effect of multiple levels of 2 factors. Now let us see the required assumptions for ANOVA test. The population from where the sample is drawn should follow normal distribution. Next is samples have been selected independently. And finally, each group should have common variance. Now let us see the steps involved in ANOVA test. The ANOVA test involves systematic steps to determine if there are significant differences between the means of 3 or more groups. Below is the step-by-step guide. In first step, we'll note down the null hypothesis, that is H0. Here we will consider that there is no significant difference between the means of samples. So we write all group means are equal, that is there is no significant difference in the means. Then we define HA, alternate hypothesis, which is opposite of H0. Here it will be at least one group mean is different or there is a significant difference between the means of samples. Next we calculate variance between the samples and variance within the samples. Then we use it to calculate F statistic, which is given by variance between groups divided by variance within groups. Then we compare the calculated value of F with the table value of F for the degrees of freedom at a certain critical level. And finally, if the calculated value of F is greater than the table value, it is concluded that the differences in sample means is significant. That is H0 is rejected and otherwise it is accepted. I hope guys you understood these steps. You will find that these steps are the same steps that we have used in student t-test and chi-square test. Now we proceed for our first example. Here given that 3 brands A, B and C of tires were tested for durability. A sample of 4 tires of each brand is subjected to the same test and the number of kilometers until wear out was noted for each brand of tires. The data in 1000 kilometers is given in the table below. and we are asked to make an analysis of variance of the data at 5% of LOS. This is the observation table. Let us proceed for solution. First, we define hypothesis, H0 and HA. In H0, we say there is no significant difference between the means of A, B and C. Therefore, in HA, we write there is a significant difference between the means of A, B and C. Next, we find the means of each group and we also find the population mean or overall mean. Mean of A is given by the formula summation x upon 4, where x are the elements of A. So it will be 27 plus 26 plus 29 plus 12 divided by 4. I found it is 23.5. Similarly, we can find out means of B, means of C, and then finally we find overall mean, that is population mean, given by summation x plus summation y plus summation z divided by 12, because there are overall 12 elements in all samples. I found mean of B is 18, mean of C is 24.75 and population mean is 22.08. Guys, you can pause the video and check the calculation if you want. Now, let us proceed to find variance between groups. Variance between groups has formula sum of the weighted square deviations divided by degrees of freedom between groups. Sum of weighted square deviation has formula Ni into xi bar minus x bar the whole square. Ni for each sample is 4 and xi bars are given here, whereas x bar is 22.08. So when we substitute it into this formula, we found this is our numerator. Degrees of freedom between groups can be calculated as 3 minus 1 because there are 3 groups. So degrees of freedom will be 3 minus 1. Finally, after simplifying, I see variance between groups is 51.5834. Now let us proceed for variance within groups. Variance within group is given by the formula summation of individual data point minus group mean the whole square divided by degrees of freedom. Here there are 3 samples, so that formula can be written as summation xi minus x bar the whole square plus summation yi minus y bar the whole square plus summation zi minus z bar the whole square divided by n minus k, where n is overall points and k is number of groups. So here n minus k, that will be 12 minus 3 is 9. So I have substituted these values into this formula. I have used different color codes to understand these calculations for various groups. I used orange color for group A calculation, blue color for group B calculation and red color for group C calculation. Let us understand group A calculation. Summation xi minus x bar the whole square. So here first xi is 27 minus group A mean is 23.5. So it is 27 minus 23.5 the whole square plus next individual data point is 26. 26 minus 23.5 the whole square and so on. Similarly, other group calculations are done divided by n minus k. When I simplify this, I found variance within group is 29.0833. Now let us substitute these values of variance within group and variance between group in F test statistics, which is given by variance between group divided by variance within group, which I see equal to 1.7736. Now after this, we observe F value from table at degrees of freedom given by number of groups minus 1 comma total values minus number of groups. Here number of groups are 3. So first parameter is 3 minus 1, that is 2, and total values are 12 and number of groups are 3. So second parameter is 12 minus 3, that is 9. So degrees of freedoms are 2, 9. Now let us calculate the F value from table at 5% LOS with degrees of freedom 2, 9. Let me take you to the table. This is F distribution table for level of significance 5%, that is 0.05. Now we search degrees of freedom 2 here in column heading and degrees of freedom 9 in row heading. So I see the corresponding F value is 4.26. Let us make a note of this in our solution. So I note down here the F table value or F critical value is 4.26. Note that F cal is less than F critical value. Therefore, we should accept H naught. When we accept H naught, we say there is no significant difference between the means. I hope guys you understood this solution. Now let me take you for the another such example. Here, to assess the significance of possible variations in performance in a certain test between the convent schools of a city, a common test was given. The results are given below. Make an analysis of variance of the data at 5% of LOS. So these are the results. A, B, C, D are different convent schools in the city. Let us proceed for the solution. First we define the hypothesis H naught and HA. As usual, we define H naught as there is no significant difference between the means of A, B, C and D. So HA will be there is a significant difference between the means of A, B, C and D. Next we calculate means of A, B, C and D and overall mean. Using formula for A, it will be summation x upon 5 because there are 5 data points in A. I found it is 9. Then we calculate mean of B, mean of C and mean of D. Finally, we go for overall mean. I found it is 11. I hope you can do these calculations on your own. Now let us proceed for variance between groups. We know variance between groups is given by sum of weighted square deviations divided by degrees of freedom between groups. The formula for sum of weighted square deviation is Ni into xi bar minus x bar the whole square. So here for group A, Ni is 5. Similarly for group B, C and D, Ni is 5 into xi bar for A is 9 minus overall mean is 11. So xi bar minus x bar the whole square. Similarly for B, xi bar is 10, 10 minus 11 the whole square. For C it is 12, so 12 minus 11 the whole square, and for D mean is 13, so it is 13 minus 11 the whole square. And since there are 4 groups, the degrees of freedom between groups is 4 minus 1. When we solve this using calculator, I see variance between groups is 16.67. Now we go to calculate variance within groups. Variance within groups is given by formula summation individual data point minus group mean the whole square divided by degrees of freedom given by n minus k. Since there are 4 groups, the individual summation individual data point minus group mean the whole square is given by this numerator. I'll use different color codes to show the calculation. Since number of data points are 20 and number of groups are 4, n minus k is 20 minus 4 is equal to 16. When you solve this using calculator, you will see variance within group is 13. Now let us substitute variance between groups and variance within group in F statistic formula, which is variance between groups upon variance within groups. When I substitute and simplify, I found calculated value of F is 1.28. Now let us observe F value from the table for the degrees of freedom given by number of groups minus 1, total values minus number of groups. Here there are 4 groups. So 4 groups minus 1 is 3. Total values are 20. 20 minus number of groups 4 is 16. So degrees of freedom here 3, 16. Let me take you to the same table for 5% of LOS and degrees of freedom 3, 16. So for 3 degrees of freedom in column heading and 16 degrees of freedom in row heading, I found the F value is 3.24. Let us note down this value in our solution. So I find F critical value is 3.24. Now let us compare F critical value with F calculated value. I see F critical value is bigger than F calculated. So we should accept H naught, and when we say so, we are saying there is no significant difference between the means of samples A, B, C and D. I hope guys you understood this example too. Now it is your turn to solve some examples. These are a couple of practice examples. Please write me in comment box whether you were able to solve these examples or not. Till I publish my next video, keep watching my videos, keep sharing my videos. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.